Okay guys, in this section 5-4 we're going to be talking about angles of elevation and depression. And so this is where we will apply what we had learned last time about the trigonometric ratios, because we will use those to set up and solve the problems that we go through in this section. Okay, so first of all, when we're talking about an angle of elevation, that's an angle, all right, from the horizontal line up to an object, right? Angle of elevation. When we're talking about an angle of depression, that's an angle from the horizontal down to the object, right? So the initial angle of the angle of elevation or depression both start from the horizontal, and then it either looks up to an object or looks down to an object. Up for elevation, down for depression, all right? And so that's kind of important for us to understand, because the problems that we're looking at will say the angle of elevation from this to that is 25 degrees. Okay, so we need to know the position of that angle and put it in the right spot when we create our drawing and set up the problem. All right? Okay, so let's see some examples here of what we'll be looking at. Okay, so this one says, okay, a surveyor is standing 50 feet from the base of a large tree. Okay, the surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. How tall is the tree? Okay, now I purposely did not give you the figure because I want you to draw it yourself. Okay, so let's look at the information and see if we can draw it correctly. First of all, a surveyor is standing 50 feet from the base of a large tree. Okay, so let's draw it. What do we need? Well, we need large tree. Okay, we need that. Okay, 50 feet away from the base of a large tree. Okay. All right, so there's where the person is standing. And then it says the angle of elevation, this is 50, we can go ahead and mark that, by the way. The angle of elevation from, right, his line of sight up to the top of the tree is 71.5. So the angle of elevation up to the top of the tree, this angle right here is 71.5 degrees. Okay, there's your angle. And like I say, since that's an angle of elevation, we know where to put the angle, and it must go here. Okay. All right. So we know not to put the 71 up here, right? And we know that this is 90, so it doesn't go here. So this is the angle of elevation once again from the horizontal up to the object. All right. So now what are we looking for? How tall is the tree? There's your x. Okay. So again, now I can use my trigonometric ratios that we learned in the last unit, or excuse me, the last section, in order to set up and solve this. So here's my reference angle. What have we got? We've got the opposite side. We've got the adjacent side. Opposite and adjacent, we can use tangent. So tangent of the angle equals to opposite over adjacent. Remember, you could also use cotangent because that's adjacent over opposite, right? It's the reciprocal. Okay, so from here, then we fill in the parts that we have, which is going to be tangent. My reference angle is going to be 71.5 equals. Now, what's the opposite side here? The opposite from this reference angle is x, and the adjacent side is 50. All right, so that's what it looks like when we plug in. And once again, just like in the last section, it's just a matter of solving for x. I'll multiply both sides by 50. By 50. That'll cancel out. It leaves me with x is equal to. So now I just need to figure out what 50 times the tangent of 71.5 is. And so let's see. We'll go back to our Desmos calculator, and we can go 50 times. Remember, on Desmos, the trig functions are under functions. Tangent 71.5. And remember, when you start using this calculator, you got to make sure it's set to degrees. So we'll come back up here, and here's where you set it back and forth between radians and degrees, because notice when I was in radians, I got the wrong answer. When I set it back now to degrees, I get the right answer, which is 149.43. 149.43. Okay? So there you go. So if this person is standing 50 feet away and has to look up 71.5 degrees to see the top of the tree, that tree is almost 150 feet tall. So large tree indeed. All right? So there you go. Let's try another one. Okay, so again, on this next one, I actually gave you the figure this time on this next one. But it says you are 200 yards from a river. Okay, so you're 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. Find the acute angle between the path and the river's edge. All right, so we're trying to find the angle from that path you take and the river's edge. So this is the angle that we're looking at. Okay, and what we're trying to figure out is if this distance is 200 and this distance is 400, then what's this angle? Well, let's look and see what parts we have so that we can decide which trig function to use. So we have 200, which is the opposite, and we have 400, which is the hypotenuse. Opposite and hypotenuse, let's use sine. So sine of the angle is equal to opposite over hypotenuse. You could also use cosecant because it also involves those two pieces. And we'll go sine. The angle is missing, so I'll change it to an x. You could leave it as a theta if you wanted to as well. And the opposite side is going to be 200. And the hypotenuse is going to be 400. All right, so this is what we need to solve for. Now, remember how we solve for one like this. In the last section, remember we said when x is wrapped up inside the sine function, we've got to do the inverse sine to both sides in order to undo it and to get the x out of there. So in an equation, whatever you do to one side, you got to do the same thing to the other side. So we must also do inverse sine to the other side. And so inverse sine of sine of x, remember those undo each other and the x falls out. Now I'm ready for the calculator to finish it up. And so all I need to do is go back to my Desmos calculator and we'll go functions. Inverse sine is what we need this time. Inverse sine of 200 over 400. Could have just made that 1/2 if you wanted to. And so the angle is 30 degrees. 30 is the correct answer there. All right, so like I say on these, if you have a drawing, great, you can set it up. If you don't have one, you can make a drawing of your own and then set it up with the correct trig function. Okay, so one more to kind of take a look at here. So let's say we wanted to find the length C of a skateboard ramp. Okay, we're trying to find this length of the skateboard ramp. They give us 4 feet at the top of the ramp. They give us this angle down to the bottom here as 18.4 degrees. And so on this one, we are they've given us the opposite and they've given us the hypotenuse. Opposite and hypotenuse. So again, opposite and hypotenuse, I could use sine if I wanted to, but since we used sine in the last problem, why don't we use cosecant this time? All right, so cosecant of the angle is equal to hypotenuse over opposite. Now let's plug the stuff in that we have. So the cosecant, my angle here is 18.4 equals to the hypotenuse, which is, we'll go ahead and write as an x. You could leave it as a c if you want to. The opposite side is 4. And so in order to solve this, I'll multiply both sides times 4. And we just get x equals, ready for the calculator now. And we will go 4 times the cosecant of 18.4. And we notice that our answer is 12.67. Okay. And so that would be the length of the ramp. All right? So now we'll kind of take these, what we've learned from these examples, and use that in order to complete the quiz. All right?